Welcome to the deep dive. It's genuinely great to have you with us today.
Absolutely glad you're here.
So today we are looking at this really fascinating paradox in the world of electric vehicles. Because if you track the data, public EV chargers are actually breaking down way less often than they did, say, a few years ago.
Right.
And yet driver frustration has hit this all-time high. So, why are drivers getting angrier about a system that is technically working better?
Yeah, it's wild.
To answer that, we really have to look past the plug itself. We're diving into the hidden, the rapidly evolving infrastructure of the EV world, because we're moving far beyond that simple, plug in your garage model.
We really are. I mean, the transition happening right now is just massive. Think about it. For a century, we built our entire relationship with transportation around this completely static model.
Right.
The car goes to the energy. You drive your car to a piece of real estate that is dedicated entirely to gasoline.
Yeah, the classic gas station.
Exactly. But forcing a highly decentralized technology like battery electrification into that old behavioral box, it's just creating massive friction.
Which is exactly why we've pulled together a really massive stack of sources to guide you through this transition today. We're looking at consumer surveys like the August 2025 J.D. Power report, market forecasts from TechSci Research, and Future Market Insights.
Oh, and those government presentations, too.
Yes, the Mass C presentations, corporate case studies from EO Charging, and breaking news from AAA and EV Infrastructure News. Our mission today is to uncover how innovations in mobile charging, robotics, and something called charging as a service are solving the biggest bottlenecks in EV adoption.
For both everyday drivers and huge commercial fleets.
Right. Okay, let's unpack this.
So to really understand the trajectory of all this infrastructure, that August 2025 J.D. Power report is, well, it's the perfect starting point.
It really is.
It perfectly captures the reality of the consumer experience right now. And as you mentioned earlier, it presents that glaring paradox.
The frustration paradox.
Right. Overall satisfaction with public charging actually dropped 10 points in 2025.
Wow.
Yeah, a 10-point drop, despite the fact that the actual reliability improved. So the metric they use for failure to charge, meaning, a driver pulls up and just cannot initiate a session because of broken hardware or a blank screen, that metric has actually gone down.
So the hardware is literally dispensing the electrons, but the experience is still just infuriating for people.
Exactly. It completely comes down to the friction of the transaction, right? And the ecosystem surrounding that hardware. The sources point out that drivers are getting increasingly frustrated by confusing payment processes or a total lack of pricing transparency.
Oh, and the fragmentation of the networks. I hear about that all the time.
Yes. The fragmentation is huge. So the hardware works, but the software handshake between the car, the charger, and the payment gateway, that is what's failing the consumer test right now.
Oh, got it.
But, the reason the hardware reliability improved in the first place is actually tied directly to federal policy shifts.
Right, because we saw significant funding shifts regarding the NEVI programs, right? The National Electric Vehicle Infrastructure Initiative.
Exactly. The administration and Congress significantly pulled back on that NEV funding. And just to be super clear for you listening, we aren't taking any kind of political stance on whether that policy shift was right or wrong.
No, not at all.
We are strictly reporting on the market's reaction, just as it's outlined in our sources. And the immediate reaction was that the private sector, specifically the automakers and local municipalities, they just stepped in to fill the void.
They kind of had to, right?
Yeah, they couldn't rely on federal deployment timelines anymore, so they just accelerated their own capital investments.
And you can really see the results of that private sector push in the network satisfaction scores. Because Tesla's supercharger network is still the gold standard here.
Oh, without a doubt.
Yeah, scoring a 709 in the J.D. Power report.
The data backs that up consistently every time. And the non-Tesla networks that are run by automakers, so we're talking companies like Mercedes, Rivian, and Ford, they are actively catching up to that 709 score.
Because they're adopting that manufacturer-centric ecosystem model, right?
Precisely. When you control both the vehicle's API and the charging station software, you can guarantee this totally seamless plug-and-charge experience.
Yeah, no weird app downloads or credit card readers failing.
Right. Meanwhile, the universal networks, the legacy companies like Blink and EVgo that are trying to serve every single make and model on the road, they're lagging at the bottom of the ratings.
Because it's too hard to make it work for everyone.
Exactly. The variable software handshakes are just way too complex to manage flawlessly across like 50 different vehicle architectures.
Okay, I have to push back a little on this whole model, though.
Yeah, okay.
Because I mean, even if a fixed public charger works perfectly and that the software handshake is flawless, the fundamental concept of a fixed public station just feels flawed for EVs.
Oh.
Well, I always compare public charging to a vending machine with surge pricing.
Ah, that's a good way to put it.
Right. Like, it is great when you find one that works and it has the exact snack you want and you're willing to pay the premium. But what if it's trapped behind a locked parking gate?
Yeah.
Or what if you arrive and there's a line of 4 cars waiting for a single plug?
Right, the spatial limitation, that's the core vulnerability of the entire system.
Exactly. And that is why I'm so fascinated by this recent initiative from AAA. According to their press release, they are expanding a pilot program offering mobile EV charging across 16 major metro areas.
That's a massive expansion.
Yeah, we're talking cities like Orlando, Denver, Grand Rapids, and San Francisco.
Yeah.
If your battery dips to zero, a specialized AAA truck just rolls up to your location and literally dispenses electricity into your car right on the side of the highway.
Just giving you enough range to get home or to a real station.
Right. It flips the entire paradigm. The energy actually comes to you.
And honestly, AAA proving this concept at scale is a really significant indicator for the broader market.
Yeah.
Yeah, because if a heavy rescue truck can effectively act as a mobile grid connection for a stranded vehicle, it naturally shifts the conversation toward everyday applications. Like, how is portability going to evolve for standard consumers?
Or commercial property owner.
Exactly. Property owners who want to offer charging but definitely do not want to pour concrete.
Which transitions us perfectly into the tech innovations outlined in the TechSci research report. Because the portable charging sector is moving incredibly fast right now.
It really is.
For the off-grid market, they highlight this company called GoSun. They launched a solar-powered charger that's designed to mount directly onto a car's roof rack.
That's pretty clever.
It is. You just park at a trailhead, unfold it, and it trickles off-grid power directly into your battery while you hike. But, okay, the technology that stands out the most to me is the FlashBot by Ion Dynamics.
Ah, yes, the autonomous charging robot.
Yes, it is basically a heavy-duty Roomba that dispenses electricity.
That's a great visual.
It's an autonomous robot that just navigates commercial parking lots. So instead of you hunting for a dedicated charging space, you just park anywhere, request a charge via an app, and this robot rolls up to your car and plugs in.
Think about the economics of this for a property owner, though.
Oh, they must love it.
They do, because you completely bypass the massive capital expenditure of tearing up your asphalt, trenching for heavy conduit, upgrading your local grid connection, and permanently sacrificing like 10 prime parking spots.
Right. You just deploy a fleet of roaming batteries.
Exactly. It solves the civil engineering nightmare of retrofitting old real estate. However, from an infrastructure analysis perspective, we do have to address the primary physical limitation noted in that TechSci report regarding these portable consumer devices.
You mean the charging speed?
Right, the charging speed.
Because we're talking about the limitations of portable level 2 charging versus DC fast charging.
Exactly. There is a real bottleneck in the physics of power transfer here. Most of these highly portable autonomous units rely on AC power delivery.
Which means what practically?
Well, it means the vehicle's onboard converter still has to do all the heavy lifting of converting that alternating current to direct current for the battery. And that process is inherently slow.
Got it. So if your car is parked at the office for 8 hours, a FlashBot is a perfect solution.
Right. But if you need a rapid turnaround, the time equation just falls apart. High voltage DC fast charging requires massive thermal management and really heavy cabling.
Stuff that's incredibly difficult to miniaturize into a little autonomous consumer robot.
Precisely. Which, this raises an important question. How do we scale mobile power for users who need massive amounts of electricity and who need it delivered incredibly fast?
And when we talk about users who require massive amounts of power instantly, we are definitely moving away from the consumer market and talking directly about commercial fleets.
Oh, absolutely. The commercial sector is entirely unforgiving when it comes to time.
Time is money.
Literally. If an everyday driver is annoyed by a 30-minute wait at a public station, a logistics company is bleeding actual revenue for every single minute a delivery van sits idle.
Wow.
In the fleet world, utilization is everything.
And the physical nightmare of electrifying those commercial fleets is just Staggering. We have a presentation in our stack from MassEC, the Massachusetts Clean Energy Center.
Oh, yeah, that one is eye-opening.
They outline the brutal, on-the-ground reality for fleet operators trying to transition. And the biggest hurdle isn't even the cost of the vehicles.
Oh, it's not.
It's the facility upgrade delays.
Yeah.
A logistics company might be ready to buy 50 electric delivery vans today, but the local utility informs them that upgrading the neighborhood substation to handle that multi-megawatt power draw is going to take 2 to 3 years.
2 to 3 years. I mean, the utility interconnect queue is the single largest bottleneck in commercial electrification right now.
And even beyond the grid constraints, you have these incredibly complex lease agreements because a massive percentage of fleet operators actually lease their depot space.
Right.
If you have a 5-year lease on an industrial lot, your landlord is incredibly unlikely to let you dig massive trenches and pour million-dollar concrete charging islands.
And even if they do let you, you cannot take that sunken capital with you when the lease ends. You just abandon it.
Exactly.
And that specific friction point has triggered a massive pivot in the market toward a financial and operational model called charging as a service, or CO.
COCO.
Yeah. And the Future Market Insights report actually projects the COS market to reach a staggering $16.8 billion by 2036.
Wow. A $16.8 billion market entirely dedicated to basically bypassing concrete infrastructure.
Yep. And the reason it's expanding so rapidly is that it fundamentally restructures the corporate balance sheet.
How so?
Historically, fleet electrification required massive upfront capital expenditures, or CapEx.
Right.
The fleet operator had to purchase the chargers, pay for the utility grid upgrades, manage the civil engineering, and hire all the maintenance crews. But the COW model shifts all of that into an operational expense, or OPEX. Oh, so it becomes like a monthly bill instead of a huge upfront hit.
Exactly. The fleet just pays a subscription or a per kilowatt hour fee, and a third party takes on all the risk of providing the hardware, the software, and the physical power delivery.
That makes total sense.
Yeah, according to the data, that subscription model currently drives 55% of the total CareAs market revenue.
55%.
Yep. Chief financial officers absolutely love this because it completely mitigates the risk of obsolete hardware and bypasses those utility delays entirely.
Okay, here's where it gets really interesting. When you combine that CareAs financial model with heavy-duty mobile hardware, you get some incredibly clever engineering solutions.
Oh, the mobile hardware is fascinating.
Right. EV infrastructure news highlighted a few of these companies recently. You have players like SparkCharge, which they just secured $30.5 million in funding.
Yeah, and they use heavy-duty battery energy storage systems mounted on commercial trailers. So a logistics company can just lease an empty lot. And SparkCharge tows a massive battery to the site, charges the fleet of vans overnight, and then literally tows it away to recharge off-site.
It allows the fleet operator to completely ignore the local utility grid's capacity limit.
Exactly.
Yeah.
But then you look at a company like L-Charge, and their approach is mechanically fascinating to me.
The L-Charge truck, yes.
They recently launched this California-built mobile charger that's based on a Ford 250 or 550 chassis. But rather than filling the bed of the truck with incredibly heavy lithium-ion battery banks to hold the charge, they utilize the truck's existing 7.3-liter gas engine and pair it with a power takeoff system, or a PTO.
Honestly, that is a brilliant piece of mechanical engineering for weight reduction alone.
I really want to break down how this works because it's so clever. A PTO is essentially a mechanical gearbox that attaches directly to the truck's transmission. So while the truck is parked and the gas engine is idling, the PTO siphons that rotational kinetic energy from the drivetrain and uses it to skin a massive heavy-duty alternator in the back of the truck.
It's acting like a mobile power plant.
Exactly. And this setup generates a direct 60-kilowatt DC fast charge without needing any intermediate battery storage at all.
You know, it sounds totally counterintuitive to use a gasoline internal combustion engine to charge an electric vehicle.
It really does.
But in an emergency roadside application or like a temporary fleet depot, the physics actually make sense. Batteries are incredibly dense and heavy. A 60-kilowatt-hour battery bank would consume the entire payload capacity of that Ford truck.
Right, we just weigh it down.
Exactly. By generating the electricity mechanically on-site using the PTO, the truck bed remains relatively empty, which allows L-Charge to use the vehicle for traditional roadside service tools as well.
Which is huge for versatility. And you also see solutions in the Cavis market like the Exos Hub and the ZVX mobile charging unit, which are essentially drop-in power banks housed in shipping containers.
Yeah, the containerized solutions.
Right. You can drop one into a leased lot, run your operations for 2 years, and if your lease ends, you just hitch it up to a semi-truck and drive your entire charging infrastructure to a new warehouse.
The versatility of these mobile microgrids is critical for the transition phase we're in right now. However, as infrastructure analysts, we really have to look at the ceiling of this technology.
Like, what do you mean?
Towed batteries, PTO generators, and autonomous robots, they are brilliant stopgaps for acute spatial and grid problems. But they do not scale infinitely.
Yeah, that makes sense. Because, if I am running a fleet of 100 city buses, I can't rely on a fleet of pickup trucks to charge them every single night.
Exactly.
So what does permanent, reliable infrastructure actually look like?
That is the ultimate test of the ecosystem. And this is where the white paper from Eero Charging provides a really crucial framework. They introduce a concept they call charge assurance.
Charge assurance?
Yeah. Their analysis shows that early fleet adopters often failed spectacularly because they treated a commercial EV charger like a traditional diesel pump.
Oh, like just plug it in and walk away.
Right. They assumed the hardware was the entire solution. They bolted chargers to the ground, plugged them in, and completely ignored the software architecture and utility grid management required to sustain it.
They treated it as a plumbing problem instead of a networking problem.
Exactly. And what's fascinating here is how EO Charging achieves their guarantee of over 99.5% uptime for commercial clients. You do not achieve that level of reliability simply by installing thicker cables.
So what do they do?
They treat the charging depot as a highly complex IT network. It requires self-healing software that constantly monitors API endpoints, automatically detecting and rebooting a stalled charging protocol before the depot manager even realizes a station went offline.
That's incredible.
It requires 204/7 remote telemetry. And most importantly, when you're dealing with a 100-bus depot, it requires dynamic load balancing.
Okay, let's dive deep into that dynamic load balancing, because the math behind it is just staggering when you scale it up to a municipal level.
It really is. Think about the power density required for heavy transit. If you have 100 electric city buses returning from their routes at 6 p.m., and they all plug into 60 kilowatt fast chargers simultaneously, you are asking the grid for 6 megawatts of instantaneous power.
6 megawatts. That will blow the transformers at the neighborhood utility substation instantly.
Oh, instantly. The local grid physically cannot handle that concurrent spike. So instead of paying the utility millions of dollars to upgrade the substation, intelligent energy management software acts as the conductor for the depot.
How does that work?
When the buses plug in, the software reads the state of charge telemetry from every single vehicle. It cross-references that data with the municipal dispatch schedule for the following morning.
So it knows exactly when each bus needs to leave.
Right. The software then dynamically throttles the kilowatt flow throughout the night. It might drop the current down to a slow 5 kilowatt trickle for a bus that doesn't need to leave until 10 a.m., while simultaneously routing maximum DC power to a bus that is completely empty and scheduled for a 4 a.m. route.
Wow.
It actively orchestrates the energy flow to keep the total depot power draw safely below a predefined 2 megawatt ceiling, completely automatically.
And when you pair that sophisticated software architecture with innovative civil engineering, you get solutions like the Stagecoach Romford Bus Depot in London.
Yes, the Romford Depot.
This case study in the EO white paper is just an absolute masterclass in urban space management, because Stagecoach was tasked with electrifying a fleet of 100 buses, but their depot in London had a painfully tiny footprint.
The spatial constraints in legacy urban depots are almost always the hardest part of the equation to solve. You just rarely have the luxury of greenfield development in a densely packed city like London.
They literally could not afford to lose the operational space required to install traditional concrete charging islands between the parked buses.
So what did they do?
So instead of building out, they built up. They installed 3 massive Kempower 600 kilowatt power routing cabinets in a remote corner of the depot. Then they ran the conduit high above the floor, mounting 20 charge boxes and 9 stem and cable reels directly onto the ceiling and the structural wall.
Suspending the infrastructure.
Exactly. The heavy power cables literally dropped down from the sky to plug into the buses. By moving the physical hardware into the vertical airspace, Stagecoach didn't lose a single square foot of drivable operational space on the depot floor.
It is a phenomenal synthesis of mechanical engineering and software management. And, to bring this back to you, the listener, navigating your daily life. The next time you see an electric city bus glide past you, or an electric Amazon Rivian van pull up to drop a package at your door, recognize the invisible logistics required to get it there.
There's so much going on behind the scenes.
There's a massive software ecosystem running continuously in the background. It is managing time of use, peak electricity rates, tracking highly specific vehicle duty cycles, communicating with local utilities substations, and performing self-healing API diagnostics at 3 a.m.
All just to get you that packet.
Right. All of that invisible work is happening just to ensure that specific vehicle secured the exact electrons it needed to make it to your street.
So what does this all mean? We started this deep dive looking at the consumer frustration captured in the J.D. Power report and the localized solution of AAA's mobile rescue trucks.
Right.
We explored the spatial economics of autonomous robots dispensing electricity in parking lots. And we scaled all the way up to the financial engineering of a $16 billion charging-as-a-service market and the IT infrastructure required to manage ceiling-mounted bus depots.
We really covered a lot of ground today.
What it all points to is that the electric vehicle revolution is not just about swapping a gas tank for a battery pack.
Yeah.
We are fundamentally rewiring how, when, and where we distribute and consume energy as a society.
It's a total paradigm shift away from centralized infrastructure. And actually, I want to leave you with a final thought to ponder, building on the trajectory of everything we've explored today.
Okay, let's hear it.
If energy distribution is becoming completely decoupled from fixed locations, if we are scaling mobile battery trailers, autonomous charging robots, and intelligent software that directs power exactly where it's needed, will the very concept of the gas station or the charging station disappear entirely?
Oh, wow.
Right. Imagine a near future where infrastructure is entirely invisible to the consumer. Your vehicle simply communicates its state of charge to the network and requests its own power from a roaming drone or an autonomous robot while you sleep in your bed.
We could be witnessing the permanent end of the errand we've all come to know as stopping to fill up.
Exactly. No more fixed destinations, just intelligent energy meeting you exactly where you are. The grid of the future won't be a place you go. It will be a service that comes to you.